Okay, let us examine these questions. There's a table given, and this experiment is to find out which material is a better conductor of heat. So you can see there's material W and material X. He recorded the temperature of hot water in each vehicle. So the temperature started at 80 degrees centigrade for both. The temperature is taken every 5 minutes. So we look at the ending temperature, 40 versus 65. 40 versus 65. So which is a better conductor of heat? They want to investigate which material is a better conductor of heat. So better conductor of heat, remember the concept, lose and gain heat faster. So it's in setup A, right? So setup A corresponds to material W. Okay. So, okay. There's no question asking you which is a better conductor of heat. They just mentioned here, maybe in the next part there. So you can actually indicate here, W, right? Maybe you just put it here to help yourself. So you just put W is a better conductor of heat. Okay, you may need this information later. Okay, since we are measuring the temperature, right, in this experiment, so you similarly indicate this size of beaker, you must keep the same, right? Material of beaker, you change. Temperature of water, you must keep the same. Okay, temperature of water is actually you measure, right? Yeah, it's not keep the same. Temperature of water, you measure, variable to measure. So you should take here. Temperature of surrounding should be kept the same. So you should get this 4 tick in these columns. Okay, next, Ali pour away all the water, okay, and filled both beakers with the same volume of water at 28 degrees Celsius. And then he placed it in the oven at 90 degrees. So now he's heating up the tap water at 28 to higher temperature. So which setup will the temperature of water increase faster? So of course, you want to increase faster, you must put in a container there's a better conductor of heat, right? Which is actually material W. So they say which setup. So it's setup A. Setup A. And then you need to explain. Okay? Because you need to explain based on here, the result here. So you should say W is a better conductor of heat than X. So W will gain heat faster than X in the oven. Thus, allowing the water to increase its temperature faster. Okay, so this part. So once again, you must indicate the reason W is a better conductor of heat than X. So W will gain heat faster than X in the oven, thus allowing the water to increase its temperature faster. Okay, because you see every time, right, when you answer, right, when they ask you this thing, the temperature of water, you must answer back this one. You must answer here, this question. So Ali want to keep the coffee warm. Okay, you see this question, as I told you, right? Want to keep the coffee warm for a longer period of time. Okay, which material should you use to hold his coffee? So now I don't want the coffee to lose heat. That means I must use what? Material X. So material X. So you should say as material X, right? as X is a poorer conductor of heat than W. So the hot coffee will lose heat slower to X, thus keeping the coffee warm longer. Okay, this part. So again, once you must indicate that X is a poorer conductor of heat than W, so the coffee will lose heat slower to X, thus keeping the coffee warm longer. Okay, next we see something interesting here. Okay, this is the fighter jet. As you can see, fighter jet, if they fly at high speed, right, the exhaust here will produce high temperature. So maybe they will reach as high as maybe like 600 degrees Celsius or even higher. Okay, during wars, right, their enemies may fire this heat-seeking missile. So this heat-seeking missile, they has the ability to detect the heat source from here, from the exhaust. So this anti-aircraft missile will keep following the heat source. So if you are a pilot in this plane, it's quite dangerous, right? If the missile hit you, right, you get killed, right, or seriously injured. So to counter this heat-seeking missile, they have developed this thing called a flare. It's being released by either helicopters or fighter jet, so that as the flare is being activated, the missile will chase the flare instead of chasing the aircraft. So when they chase the flare, right, this part, the missile will hit it and it will detonate. So the pilot will escape unharmed. So I'd like to show you a video that this thing actually happens in real life, how this heat-seeking missile work. So you sit back and relax this video as I can show you here. It's taken from a movie called Behind Enemy Lines. Hopefully you can see, are you able to see this, Anna?
Yeah.
What is it? Holy shit, we're being painted! What?
Okay, the heat-seeking missile has just been fired.
Shit, they fired! Scoop it now! Pull up! Get the nose!
So it's pulling higher to escape the missile.
Roger! I see a single missile tracking on us. I don't see it. Call my turn. Just slice left. Hard!
Okay, this missile actually fly very fast. It can fly as fast as like 3,000 kilometers per hour. But the fighter jet maybe fly only about 2,000 to 2,500 kilometers per hour.
Jesus Christ! Where is it? Try to break the lock!
So it's tracking it, tracking the heat source. So it's being locked onto the heat source.
Golden Eagle Archangel, we have been engaged! Roger. You want quantity too? Put out decoy flare! Copy. Hang on!
Okay, you notice here, they let out the flare. So this sort of flare is actually high temperature. It's like a small explosive to so-called prevent the heat-seeking missile from continuing chasing the aircraft. So the pilot hope that the heat-seeking missile will chase this thing. But you see this part, right? I rewind a little bit. They did not hit it, okay? Maybe he released too early or too late. I think he released too late, if you can see here. Yeah, he released a bit late. Maybe like 1.2 seconds or 1.5 seconds late.
Where is it? Goddamn it. Where is it? I can't see shit. Where is he?
can't see. Okay, you see this part? The heat source from the engine is very high, as I told you, can be as high as 600 degrees Celsius or even higher. So this missile is actually tracking the heat source. And the enemy fire a second one. So the SAM is called surface to air missile, SAM. So the pilot is in real danger. There are two missiles chasing him.
We need a bigger heat decoy.
Okay, they say he need a bigger heat decoy. Decoy is to like distract the missile. So let's see how you activate a bigger heat decoy.
We're screwed. Missile's launching. 1 mile. Drop the fuel tank and pull out.
So the commander told him to drop the fuel tank. Okay, can you see the aircraft here outside, right? There's these two structures. They actually carry so-called the aviation fuel, or in car we call the petrol. Is like as heavy as 1,000 kilograms. This one is an external fuel tank. So the commander asked him to drop the fuel tank. Okay, the first fuel tank hit the snow. Because the snow cushioned it, it didn't explode. Okay, let's see the second fuel tank. Okay, the second one exploded, maybe hit the road surface, exploded in a huge fireball. So the heat source from this fireball, right, may be greater than from the engine. Okay, from the engine. So we'll see whether the missile will be decoyed to hit here instead of continue chasing the aircraft. Okay, you see, yeah, the fire. Okay, both going to the fireball. One actually being neutralized, it exploded in the fireball. Okay, but the other one is still chasing the pilot. The other missile is still chasing him.
Where's the second? No joy, I don't have it in sight.
Okay, the second one is still chasing the pilot.
Push over. Turn left. I'm going for a head-on pass. Here he comes, head on right side.
So this part, I just stop the sharing. So from there, you can see, right, the science in this lesson can be quite interesting. So back to this screen. So one of the missile is being attracted to hit the decoy. The other is still chasing the pilot. So you want to find out the outcome. Okay. Join one academy to find out the result for this race. So today we have covered a few concepts on heat. So I hope you can revise all these concepts that I've covered. Heat is an important topic in PSLE. In the past year, up to 10 marks are being tested on heat questions. So heat question, as I mentioned, is actually a P4 topic. Okay, P4 topic. So today I'm actually doing revision from this week. I'll revise the P4 and P5 topic to prepare the students for the coming P6 SA1. So I wish you all the best. Stay safe. Take care. God bless.